Hello, everybody, and welcome back to KringleCon. Once again, a huge thank you to Mr. Claus for having us up here, and Mrs. Claus. I don't know if you guys are aware of this, but Mrs. Claus makes the absolute best cookies in the whole wide world. So I'm basically letting you all know this because kids, you better start upping your cookie game because you're going to do nothing but disappoint Santa whenever he comes to your house on Christmas Eve. All right, so I wanted to give another presentation on creating a malware zoo and doing malware analysis. So let's dive right in. The first thing that you're going to have to do when you're setting up your malware zoo is you're going to have an overall concept of what the design is going to look like. Generally, whenever we're creating a malware analysis lab for creating malware for implants or doing detection with Rita and doing analysis, we create an Active Directory environment. We infect a single system on the inside of that environment, and then we have a Bro or Zeek, as it's now called, and Rita system that's watching all of that traffic that is leaving that particular environment. And this is key because you want to have that level of visibility. Now, some people would argue that you would need full PCAPs and full TCP dump. That'd be great if everybody could do that. That would be just fantastic, but a lot of organizations have very limited number of span ports that they can use for the egress traffic, so that may not be available. So just try to tie up just Bro and Rita. Don't try to get too crazy with what you're trying to capture. Also running VMware. VMware is absolutely essential. This is my lab. This is what I use all the time for doing analysis with Rita and Active Countermeasures AI Hunter. And this particular lab can scale anywhere from like a handful of systems, like 20, all the way up to about 70 to 80 systems. It depends on how crazy I want to get with the lab that I'm trying to create. And VMware is just fantastic for that. Also, Bro Zeek. Bro is amazing. We should do a number of, we should all get together here. I think that there's some like ship a little bit south of us. I think some researchers got stranded there and possibly died horrible, painful, cold deaths. We can all meet there because I think all the food stores are there and I think all the liquor is there, but we can all get together later and we can just do a tabletop session and talk about Bro. But Bro actually decodes a large amount of data. It automatically identifies DNS data, HTTP data, HTTPS data, TCP connections, it slices, it dices. It is fantastic. And Rita rides on top of Bro. Also, generating noise is important. Anytime you're trying to analyze any network intrusion detection product, it is really easy to say that the product works whenever it is just watching 4 computer systems and one of those computer systems is making an outbound connection. That's just stupid easy to do. So this is one of the cool tools that we created at Black Hills Information Security. It was one of the first things that a systems administrator that I hired, Kent, who's now one of our pen testers, did when he joined BHIS. He came on board. I'm like, here's what I want. I want a PowerShell script that pulls down the Alexia Top 500, picks a system or a website in the Alexia Top 500, and then surfs to that website for 5 minutes, closes the connection, and then opens up and starts surfing again. So it generates a tremendous amount of white noise because literally every single system in this environment is making those outbound connections like a standard user would be making those outbound connections. This allows you to see how well your implant blends in with the white noise, and it also allows you to kind of get a baseline on how effective your network intrusion detection system or your extrusion detection system is at detecting attacks as well. So check it out. Now, the goals and objectives, we don't want to get lost in the weeds. It's about identifying and understanding very specific malware samples. This would be malware samples that you want to recreate in a lab to test a product. This would be malware samples as a red teamer that you want to generate and see if its profile is going to be easily detected by a target organization that you're doing an assessment on as well. And we really want to start looking at this as something that should be done structurally across the board. You should be constantly testing your IDS, IPS, user behavioral and entity analytics, your antivirus products as much as you possibly can, and trying to create that malware zoo will allow you to develop the skills and the techniques to fully vet all of the security products that are out there right now. So watching the malware. So whenever I'm running malware on a system, I'll be watching and making sure that it actually fires off. Like it'll basically pop up and let me know, yes, it is in fact working. I will also name my malware something that's easy for me to identify in that noise. This is all part of an effort to make sure that it's working properly. So in this example, I named my malware beacon.exe because it's a beacon. And then I ran a little PowerShell script, netstat minus naob 5. We're going to pull through select string, batch the pattern beacon, and then we're going to kick it out to a file called beacon.txt. This is a quick way for me to be sure that the beacon is firing and it does not go down. So the Black Hills information security testers, they actually hate me. A lot of the testers are constantly creating malware specimens, dropping malware specimens in the lab or even in customer networks where we have Rita set up for them. And they basically say, go and try and check this malware as well. So there's lots of custom malware that they generate all the time. There's a lot of off-the-shelf malware that they create as well. And you don't have to be a tester to create malware. There's tons of examples, easy things that you can do in Metasploit. And if you go out and get a tool like Cobalt Strike, it makes it super duper simple to create tons of different command and control profiles. So let's start with Joff. So Joff is kind of the lead tester for creating malware at Black Hills Information Security, constantly creating payloads and backdoors that other testers are using, and constantly coming up with new techniques to bypass endpoint security products. That's just kind of Joff's gig, right? And that would make sense. I mean, the guy is an instructor of the Python class, and that's just what he does. So he, out of everybody, probably has the biggest vested interest in trying to find a way to bypass Rita, because if any of my testers are working on an engagement and Rita's catching them, he immediately is going to get that phone call. So Joff created a backdoor called Molerat with the help of a lot of other testers, Egypt and Marcello and Matt Toussaint and Dakota. All of these testers got together and kind of created a backdoor implant framework that we use on our engagements. And he set up all kinds of fun things. He set up jitter. He set up all kinds of different profiles for what is the interval for that jitter, and just a really cool tool. Well, here's the deal. If you have an attacker that's creating super advanced malware, it's not enough just to be able to analyze that malware based on its interval. So if you're confused as far as what interval actually means, interval is a lot like a heartbeat. So if you have a heartbeat can be relatively slow, or the heartbeat could be really, really fast as well. So we can identify that heartbeat. What is the consistency in the connections that are coming outbound? So an attacker can actually randomize that heartbeat and make it a little bit more difficult for a lot of tools to detect that interval. However, if you take the output of a tool like Rita and you sort it by the number of connections, some really cool things come about. In this particular example, a 24-hour period of time, Joff's backdoor had a relatively low score on the interval. It only had a 0.79 interval. It means it was not a perfect interval. But whenever you coupled that with the connections, you sorted it on the interval and then by the connections, you saw that his backdoor had 72,243 connections. That's because that backdoor was an interactive backdoor that was being used by the team at that specific time. So you could actually see that backdoor, you could work with that backdoor, interact with that backdoor. That's basically means it had to be responsive. So whenever you start coupling the overall beacon score with the number of connections, you start getting increased visibility in finding a number of different interesting backdoors. So this is Derek's backdoor. Derek Banks is another tester. Derek went even further. He actually went through and created a Cobalt Strike backdoor that was going through domain fronting, specifically through CloudFront. So it went like when the malware goes and runs, it fires up, it makes a connection out to CloudFront. CloudFront looks inside of that HTTP header, and inside of it, it says host, and then it says, here's the IP address where you should forward that traffic. It's almost like a proxy for web content. And with that proxy for web content, it can make it very difficult to detect because many security products will ignore everything that goes to CDNs. They'll ignore everything that goes to social media sites like Google or Facebook. They'll just ignore it because it's so much traffic, and the odds of it being malicious are actually pretty low. Also, he added in all kinds of randomization and also sleep in this backdoor as well. And yes, we could detect Derek as well. Once again, when you have that overall score and the number of connections combined with each other, it gave you the ability to find this backdoor. The other thing that was really neat, and it's not up here, is the dispersion was very even. A lot of backdoors out there today, they will randomize their intervals. Let's say there's a 10-second interval I want you to connect outbound, plus or minus 2 seconds. And what you end up with is 50% of the connections are going to be between 10 and 12 seconds. And you're going to have 50% of the connections are going to be between 10 and 8 seconds. When you have that flat kind of background between 50% on one side, 50% on the other side, that flat dispersion, it means that you have another backdoor in your environment. So that's pretty cool. It's a cool way to take the output of a tool like Rita, import it into a spreadsheet, sort it, and then find backdoors on a network. So lessons learned, additional things that we've discovered. One, DNS and NTP generate a ton of beaconing noise. When you're setting up your malware zoo, you may have to go through and find a way to deal with that traffic. In short, you may want to filter that out for something like a beaconing algorithm, but you still want that analysis to be done for like, let's say subdomains or hosts on a domain as well. Domain fronting is tough to catch, really, really tough to catch, folks. We've got to be careful. A lot of security products aren't doing really well. Unfortunately, major vendors are saying, oh, we're going to do away with domain fronting. We're just going to get rid of that. Unfortunately, we're not seeing it disappear, and that's kind of sad. So we can't just hold on to beaconing. It's going to require us to start doing cross-referencing across multiple different aspects of how malware actually makes a connection outbound. So beacon and connection count, combining those two is just one example of how we can do that as well. Crypto, I spent a lot of time in the past few months doing analysis on blockchain technology and cryptocurrencies. I had some contracts with the Department of Defense, and I also wanted to have conversations where I could sit down with Bo and Mike and they wouldn't look at me and say, oh, aren't you cute? Here's your Happy Meal. Why don't you go sit in the corner while we talk about real stuff? So I really dove into blockchain and cryptocurrency for a while. And we found out in a lot of the hunt teams that we're doing, the malware that we're actually detecting isn't even really malware. It's actually cryptocurrency mining, usually Monero running on a system, or systems administrators running multiple systems running NiceHash on thousands of computer systems. So how do you actually go through to detect those backdoors as well? Does it beacon? Well, it turns out in the example of NiceHash, no, it doesn't. It doesn't actually beacon at all. Once again, we have to move beyond just looking at beaconing. What are some other attributes for this potential malware communicating outbound? And we can instead look at it from the perspective of how long does that connection stay alive. And in this example, we had this backdoor. It was in this situation, it was NiceHash, which wasn't a backdoor, it was just beacon. It was just cryptocurrency mining. And instead of beaconing, it would establish a full connection and never tear that connection down. And this is interesting. This is interesting for a number of reasons. This is interesting because if we go back in time, about 8 years ago, a lot of malware that was out there would actually establish connections, keep those connections up and running the whole time. Like it would be hours, days, weeks, months, years, and that's just how the malware worked. Then a lot of security products started getting really smart about that and identifying really long-lived connections, and then would alert people on their firewall rules about these long-lived connections. So then malware switched to beaconing. It would basically pulse out an HTTP or an HTTPS session. Now you're starting to see tools that are actually detecting that beaconing. So now we're seeing malware, and in this situation, crypto miners, go back to establishing long-held connections. So the easiest way to bypass beacon detection, just don't beacon. It's much easier that way. So we need to be looking at beaconing, total number of connections, some mathematical attributes of those connections, and then also looking for really long connections as well, which once again, Rita is free and it does all of these. If you'd like to get some malware, Lenny Zelstra has a great webpage with a ton of resources where you can download all kinds of different malware. And I know that this is important for a lot of you because you may not know how to create malware. Metasploit may freak you out a little bit, and that's fine. Just go download malware. Just do me a solid favor. Don't run this on your production network. Pretty please, just don't do that. Once again, this is Malware Zoo, creating a Malware Zoo to test our implants, to test our security products. It's not malware, oh my God, everything's on fire, everyone run. Once again, please don't do that. We're in the North Pole. Things don't burn here. But I wanted to finally say thank you very much. I've provided my phone number, my Twitter handle, my websites that I'm at. Please check it out. Once again, I'm like a NASCAR driver with all of these different organizations that I work with. So thanks again, everyone. Stay warm and don't forget to check out Mrs. Claus's cookies.